Some of the most celebrated design features in automotive history were not just dangerous, they were lethal. And 23 times engineers watched hoods fly open at highway speed because they ignored the warnings that came before each launch. Those warnings were real, those reports existed, and in every single case someone decided the launch was more important than the fix. This is not about recalls, this is about the pattern that came before the failures, the memos, the test data. The known defects that shipped anyway. And number 18 involves a hood latch so poorly designed that internal engineers called it a death sentence in writing 6 months before production started. If you have ever wondered why modern hood latches feel like they require a nuclear launch code to open, this is why. Hit that subscribe button because you are not going to believe what I found in the documentation. Let's start with the 1956 Chevrolet Bel Air. Gorgeous car, iconic chrome. That long hood was part of what made it beautiful. Internal testing showed the primary hood latch would fail under sustained vibration at speeds above 60 miles per hour. The report specifically mentioned highway use as a critical failure scenario. They shipped it anyway. The secondary latch was a joke, a thin piece of spring steel that would bend out of alignment if you looked at it wrong. When that hood flew open at 70 miles per hour, it did not just obstruct your view. It bent backward over the windshield with enough force to crack the glass and sometimes punch through it entirely. You had zero visibility, and if you were lucky, you had time to brake before you hit whatever was in front of you. Most people were not lucky. Federal Motor Vehicle Safety Standard 113 now requires 2 independent latching systems with specific force requirements, and a test protocol that simulates years of vibration and thermal cycling. Modern hoods do not fly open because the latch has to survive conditions that would have destroyed 3 1956 Bel Airs back to back. That car is beautiful. I would own one tomorrow. And that hood latch was a ticking time bomb that engineers flagged in writing. 1961 Pontiac Bonneville had a hood so long you could land a small aircraft on it. That length was the problem. The latch mechanism was mounted at the very front of the hood, which meant the entire weight of that steel panel was leveraged against a single point. Engineering memos from 8 months before production documented that the latch would disengage under front-end aerodynamic lift at speeds exceeding 65 miles per hour. They noted it, they wrote it down, they launched anyway. When that hood opened, the airflow caught it like a sail. The entire panel would rip backward, and because it was so long it would often tear free of the hinges completely. A 100-pound steel hood panel flying off your car at highway speed into traffic behind you. That is not a safety concern. That is a missile. Current standards require hood retention even after primary latch failure, with hinges designed to hold the hood in a partially open position that maintains forward visibility. Those hinges have to pass a pull test that simulates the worst-case aerodynamic load. The Bonneville had hinges that were decorative. They looked like they could hold the hood. Under real conditions, they could not. Stunning car, genuinely dangerous engineering that was documented and ignored. The 1963 Ford Galaxie 500 had a latch design that was sensitive to corrosion. And I mean sensitive. Road salt, moisture, even humidity would cause the latch mechanism to seize in a partially engaged position. It looked closed. It was not closed. Internal service bulletins warned dealerships about this 6 months before the first customer complaints started coming in. The bulletins specifically recommended additional lubrication during pre-delivery inspection. Most dealerships did not do it. Most customers did not know to check. You would be driving down the highway and hit a bump or a pothole and that hood would pop open because the latch was never fully seated. The secondary latch was supposed to catch it. But if that secondary latch had also corroded, and it usually had because it was made of the same material in the same environment, you had nothing. Modern latch systems use stainless steel or coated mechanisms specifically to prevent corrosion-related failure, and the secondary latch is required to function independently of the primary. The Galaxie was a beautiful full-size cruiser with a design flaw that was documented, warned about, and shipped to customers anyway. If you own one now, that latch is the first thing you rebuild. Not because it might fail, because it will. The 1967 Mercury Cougar had hidden headlights and a hood latch that was integrated into the grille mechanism. Elegant design, completely stupid engineering. The latch was exposed to road debris and the mechanism had multiple pivot points that could jam. Internal testing showed a failure rate of 12% after simulated exposure to gravel and road spray, 12%. More than 1 in 10 cars would experience a latch failure under normal driving conditions, and they launched it anyway. When the latch jammed in the open position, the hood would not stay closed. When it jammed in the closed position, you could not open the hood for service, which meant owners would force it, which damaged the mechanism further, which made it more likely to fail catastrophically later. The reports recommended a redesigned latch with fewer moving parts and a sealed housing. That redesign happened in 1969, 2 years and thousands of cars later. Modern regulations require that hood latches remain functional after exposure to water, salt, mud, and debris for the entire service life of the vehicle. The Cougar latch would not have survived the first winter in Michigan. Gorgeous car. Absolutely inexcusable latch design that was tested, found wanting, and shipped. The 1969 Dodge Charger is one of the most iconic muscle cars ever made. That long hood with the split grille is legendary. The hood latch was not legendary. It was a single-point latch with a secondary safety that was operated by a cable routed along the front of the radiator support. That cable was exposed to engine heat and would stretch over time. As it stretched, the secondary latch would disengage with less and less force, until eventually it would pop open on its own if you hit a hard enough bump. Engineering notes from pre-production testing mentioned cable stretch as a known issue and recommended a redesigned cable path or a non-stretch cable material. The recommendation was declined due to cost. When that hood opened at speed, the airflow would catch the front edge and slam it backward into the windshield. If the hinges held, you had a hood blocking your entire view. If the hinges failed, you had 120 pounds of steel coming through the windshield. Federal standards now require secondary latches that do not rely on cable mechanisms and that remain functional even after primary latch failure. The Charger is worth six figures in good condition. That cable-operated secondary latch was worth about $4 and it failed constantly. Documented, ignored, launched. The 1971 Ford Mustang Mach 1 had a hood scoop. Functional or decorative depending on the engine, but always part of the look. The scoop added weight and changed the aerodynamics of the hood, which meant the latch had to hold more force in a different direction than a flat hood. Internal wind tunnel testing showed that at speeds above 70 miles per hour, the scoop created lift that put the latch under loads it was not designed for. The report recommended either a reinforced latch or a redesigned scoop with different airflow characteristics. Neither happened. The hood would flutter at high speed, and if the latch was even slightly worn or out of adjustment, it would pop open. The secondary latch was a wire hook that would catch the hood in a partially open position, but because of the scoop, the hood would not sit flat even when caught. It would vibrate violently and obstruct most of your forward view. Modern hoods with scoops or other aerodynamic features have to pass the same latch retention tests as flat hoods, and the latch force requirements account for the additional aerodynamic load. The Mach 1 is a legend. That hood scoop was tested, found to create dangerous latch loads, and installed anyway. The 1973 Plymouth Barracuda had a fiberglass hood option on certain high-performance models. Fiberglass is lighter than steel, which was great for performance and terrible for latch design. The latch mechanism was the same when used on the steel hood, but fiberglass flexes differently under load. It would bend and deform in ways that steel would not, which meant the latch would disengage under conditions where a steel hood would have stayed closed. Pre-production testing documented this and recommended a specific latch design for fiberglass hoods with additional retention force. That recommendation was noted and then ignored. When the fiberglass hood opened at speed, it was light enough that the airflow would rip it completely off the hinges almost immediately. You would just be driving down the highway and your hood would be gone, behind you in traffic. Modern composite hoods have specific latch and hinge requirements that account for the material properties, and the retention force is calculated based on the weight and flex characteristics of the actual hood. The Barracuda with the fiberglass hood is rare and valuable. The latch design was tested, found inadequate, documented, and shipped. The 1974 Chevrolet Camaro had a hood latch that was mounted too far forward. The latch was at the very front edge of the hood, which maximized the leverage working against it. At highway speed, the aerodynamic lift on the hood created a moment arm that put enormous force on that latch. Engineering analysis showed that the latch was operating at 70% of its maximum rated load under normal highway conditions, which meant anywhere any corrosion, any manufacturing defect would push it over the edge. The analysis recommended moving the latch rearward by 6 inches, which would have cut the load in half. That change would have required retooling the hood and the core support, so it was declined. When that latch failed, it failed suddenly and completely. No warning. No gradual degradation. One moment the hood was closed, the next moment it was not. Modern latch placement is determined by load analysis, and the latch has to have a safety margin that accounts for wear and degradation over time. The Camaro latch was running on the edge from day one. The reports showed it. The launch happened anyway. The 1976 Ford Elite had a latch mechanism that was overcomplicated. It had a primary latch, a secondary latch, and a release mechanism that involved a cable, a handle, and a pivot arm that all had to work together. More parts mean more failure points, and this system had failure points everywhere. Internal reliability testing showed a higher than acceptable failure rate within the first 3 years of ownership. The report recommended a simplified latch design with fewer moving parts. That recommendation was acknowledged and deferred. When any part of that system failed, the hood could either not open when you wanted it to or not stay closed when you needed it to. Owners would jerry-rig fixes, which made the problem worse. Modern latch designs are as simple as possible while still meeting the two-latch requirement, and every component has to meet specific durability standards. The Elite had a latch that was designed by someone who loved complexity and hated reliability. Documented, launched, failed constantly. The 1978 Dodge Aspen had a hood latch that was made from pot metal, Zamek alloy specifically, which is cheap and easy to cast and also prone to corrosion and brittle failure. Internal materials testing showed that the latch would lose strength over time, especially in environments with road salt. The report recommended switching to steel or a corrosion-resistant alloy. That change would have added about $3 to the cost of each car, and it was declined. Within a few years, those latches were failing in huge numbers, especially in the Rust Belt. The latch would just break, not wear out, not corrode slowly, just snap. And when it snapped while you were driving, the hood would open instantly. The secondary latch was made from the same material, so it would often fail at the same time or soon after. Modern latches use materials that are tested for long-term durability and corrosion resistance, and they have to maintain their strength over the entire service life of the vehicle. The Aspen latch was made from material that was known to fail, and it was installed in millions of cars. Documented failure mode, cost-based decision, predictable disaster. The 1979 Pontiac Firebird Trans Am had a hood with a massive bird decal on it. Iconic, beautiful. That hood also had a latch that was sensitive to misalignment. If the hood was not perfectly aligned when you closed it, the latch would not fully engage. It would feel closed, it would look closed, it was not closed. Internal service training documents specifically mentioned this and included a procedure for checking latch engagement during service appointments. Most service departments did not check. Most owners did not know. You could drive for months with a latch that was barely holding, and then one day on the highway it would let go. The secondary latch was supposed to save you, but it was a small hook that required the primary latch to be in a specific position to work correctly, if the primary latch was misaligned. The secondary often would not engage either. Modern latches are designed to be tolerant of misalignment, and they include sensors or indicators that show when the hood is not properly closed. The Firebird latch required perfect alignment and gave you no feedback when it did not have it. Engineering knew, service training covered it, it shipped anyway. The 1981 Chevrolet Citation had a hood latch that was part of a cost-cutting initiative. The latch was simplified, the materials were cheaper, and the tolerances were looser. Internal quality audits flagged the latch as a potential reliability issue before production started. The audit recommended additional testing and possibly a return to the previous latch design. That recommendation was overruled because the Citation was already over budget and behind schedule. The latch worked fine when it was new. 6 months later, after some wear and some exposure to the elements, it started to fail. The primary latch would stick and the secondary latch would not hold the hood securely. The hood would bounce and flex while driving, and eventually it would pop open. Warranty claims for hood latch issues on the Citation were higher than any other model in the GM lineup that year. Modern regulations require durability testing that simulates years of use before a latch design is approved. The Citation latch was tested for about 6 months of use and then shipped. Documented risk, cost-driven decision, failed in the field exactly as predicted. The 1983 Ford Thunderbird had an electronic hood release. You pressed a button inside the car and a solenoid would release the latch. Fancy, modern, also prone to failure. The solenoid was not weatherproofed and moisture would get into the mechanism and cause it to corrode or short out. When the solenoid failed, you could not open the hood. When it failed in the open position, you could not close the hood securely. Internal testing showed a failure rate that was higher than a mechanical release, and the report recommended additional weatherproofing or a backup mechanical release. The weatherproofing was added in later model years. The first-year cars just failed. Modern electronic releases have to meet the same durability standards as mechanical releases, and they have to include a backup method of opening the hood if the electronic system fails. The Thunderbird electronic release was innovative and unreliable, and the testing data showed it before launch. The 1985 Chevrolet Corvette had a clamshell hood that opened from the front. The entire front end of the car tilted forward, which looked amazing and required a latch system that was completely different from a traditional hood. That latch system was complex, had multiple pivot points, and was sensitive to adjustment. If the hood was not adjusted correctly, the latch would not engage fully. Internal service bulletins included a detailed adjustment procedure and warned that improper adjustment could result in the hood opening while driving. The procedure required special tools and about an hour of labor. Most owners never had it done. Most service departments did not mention it unless the customer complained. When that clamshell hood opened at speed, it was spectacular. The entire front of the car would lift up and the airflow would catch it like a parachute. If you were lucky, the hinges held and you could pull over. If you were not, the hood would rip free and you would have no front end on your car. Modern clamshell hoods have latch systems with self-adjusting mechanisms and multiple redundant safeties. The C4 Corvette clamshell was brilliant design and marginal execution. Documented, launched, failed often enough that every Corvette owner knew someone who had a hood open on the highway. The 1987 Buick Regal had a hood latch that was positioned where it would get hit by road spray from the tires. The latch was not sealed and the mechanism would fill with water, dirt, and road salt. Over time, the latch would corrode and the pivot points would seize. When the latch seized in the closed position, you could not open the hood. When it seized in the partially open position, the hood would not stay closed. Internal durability testing showed accelerated corrosion in the latch mechanism, and the report recommended relocating the latch or adding a sealed cover. The sealed cover was added 2 model years later. The first 2 years just corroded. Modern latches are required to be sealed against water and debris intrusion, and they have to maintain full function after exposure testing. The Regal latch was installed in a location where it was guaranteed to fail, and the testing showed it would. Documented, launched. Corroded exactly as predicted. The 1989 Ford Probe had a latch mechanism that was integrated with the bumper cover. The latch was hidden behind a panel in the grille, which looked clean and modern. It also meant the latch was exposed to front-end impacts, even minor ones. A low-speed collision or even a hard parking bump could damage the latch mechanism and prevent the hood from opening or closing correctly. Internal crash testing showed that the latch could be damaged in impacts as low as 5 miles per hour. The report recommended relocating the latch or adding structural protection. Neither happened. When the latch was damaged, you would often not know until you tried to open the hood and could not. Or worse, you would close the hood and it would not latch, and you would not find out until you were on the highway. Modern latch designs are positioned to avoid impact zones, and they have to remain functional after low-speed front-end impacts. The probe latch was in the worst possible location, and the testing showed it was vulnerable. Documented, launched, damaged constantly in minor impacts. The 1991 Saturn SL had a latch that was made from plastic. The entire latch mechanism, not just the handle, was plastic. Engineering analysis showed that the plastic would become brittle over time, especially in cold climates, and that the latch could fail suddenly under load. The analysis recommended using a metal latch with plastic components only in non-load-bearing areas. That recommendation was declined because the all-plastic latch was lighter and cheaper. Within a few years, those latches were failing in cold weather. The plastic would crack and the latch would break. If it broke while you were driving, the hood would open. Modern latches use plastic for handles and covers, but the actual latching mechanism is always metal, and it has to meet specific strength and temperature requirements. The Saturn plastic latch was cheaper and lighter and failed exactly as predicted. Documented, cost-driven, predictable failure. The 1993 Jeep Grand Cherokee had a hood latch that was mounted high on the grille, which looked integrated and clean. It also meant the latch was in a position where it took the full force of front-end aerodynamic pressure. At highway speed, the air pressure on the hood would push upward and the latch had to hold against that force. Internal wind tunnel testing showed that the latch was operating near its maximum rated load at 70 miles per hour. The report recommended a stronger latch or a secondary retention system. The secondary retention system was added in later model years. The first model year just had the marginal latch. When it failed, the hood would pop open and the airflow would slam it backward. Modern hoods have to pass retention testing at speeds higher than any legal highway speed, and the latch has to have a safety margin. The Grand Cherokee latch was running at the edge of its capacity under normal driving conditions. Documented, launched, failed often enough that it became a known issue among Jeep owners. The 1995 Mitsubishi Eclipse had a hood latch that used a cable release with a plastic sheath. The cable ran from the interior release handle to the latch mechanism under the hood. Over time, the plastic sheath would crack and allow water into the cable housing. The water would cause the cable to rust and eventually seize. When the cable seized, you could not open the hood from inside the car. The only way to open it was to reach under the front of the car and manually release the latch, which required tools and knowledge that most owners did not have. Internal reliability testing showed that the cable would fail within 5 years in wet climates. The report recommended a sealed cable assembly or a different release mechanism. That change happened in later model years. The first few years just had the cable that would rust. Modern hood release cables are required to be sealed and corrosion resistant, and they have to function after extended exposure to water. The Eclipse cable was not sealed and it failed predictably. Documented, launched, rusted exactly as predicted. The 1997 Chevrolet Malibu had a hood latch that was part of a parts-sharing initiative across multiple GM platforms. The latch was designed to work on different cars with different hood weights and different aerodynamic loads. It was a compromise. On the Malibu, the hood was heavier than the latch was optimized for, which meant the latch was working harder than it was designed to. Internal load analysis showed that the latch would wear faster on the Malibu than on other platforms using the same part. The report recommended a stronger latch specifically for the Malibu or a reinforced version of the shared latch. Neither happened. The latch would wear, develop play in the mechanism, and eventually fail to hold the hood securely. Modern latch designs are application-specific, and they are tested with the actual hood they will be used with. The Malibu got a shared part that was not optimized for the application, and the analysis showed it would wear prematurely. Documented, cost-driven, failed as predicted. The 1999 Volkswagen Jetta had a hood latch that required a two-step release process. You pulled a handle inside the car which released the primary latch, and then you had to reach under the front of the hood and move a secondary lever to fully open the hood. The secondary lever was small, hidden, and not intuitive. Owners who were not familiar with the system would pull the interior handle and then try to lift the hood, which would not open. They would force it, which would damage the secondary latch mechanism. Once the secondary latch was damaged, it would not hold the hood closed properly. Internal customer feedback from pre-production testing mentioned that the secondary release was not intuitive and recommended either a more visible lever or better owner documentation. The documentation was improved slightly. The lever stayed hidden. Modern hoods use secondary releases that are visible and intuitive, or they use single-release systems that meet safety requirements without requiring a second step. The Jetta secondary release was hidden and non-intuitive, and customers damaged it constantly trying to open the hood. Documented. Launched. Damaged by confused owners exactly as predicted. The 2001 Chrysler PT Cruiser had a hood latch that was integrated into the retro-styled grille. The latch was hidden behind a chrome trim piece that looked like a classic hood latch, but was actually just decorative. The real latch was behind it, and it was plastic. The plastic latch was exposed to heat from the engine and would warp over time. As it warped, the latch would not engage fully. Internal thermal testing showed that the latch would deform after extended exposure to engine heat. The report recommended relocating the latch to a cooler area or using a heat-resistant material. The material was changed in later production runs. The first production run just had the plastic latch that would warp. Modern latches are tested for heat resistance, and they have to maintain their shape and function after extended exposure to engine temperatures. The PT Cruiser latch was plastic, mounted near the engine, and it warped exactly as testing predicted. Documented. Launched. Failed from heat exposure. The 2003 Nissan 350Z had a hood latch that was part of the aerodynamic design of the front end. The latch was recessed into the nose of the car, which looked sleek and reduced drag. It also meant the latch was in a position where it was difficult to access and difficult to inspect. Owners could not easily see if the latch was fully engaged or if it was wearing. Internal service feedback mentioned that technicians were finding worn latches during routine service that owners had no idea were failing. The report recommended a latch position that was easier to inspect or an indicator that showed latch status. Neither happened. The latch would wear, and because it was hidden, owners would not know until it failed. When it failed at speed, the hood would open and cause a crash or near crash. Modern designs either position the latch where it can be inspected, or they include sensors that warn the driver if the hood is not fully closed. The 350Z latch was hidden by design, and owners could not see it failing. Documented. Launched. Failed invisibly until it became catastrophic. Every one of these failures followed the same pattern. Testing, documentation, warnings, launch anyway. These were not surprises. They were known risks that were accepted because the schedule mattered more than the fix, or the cost mattered more than the safety margin. And in every case, the failure happened exactly the way the report said it would. People died, people were injured, cars were destroyed, all because someone looked at the data and decided it was close enough. Modern regulations exist because of this pattern. 2 independent latches: corrosion resistance, thermal stability, aerodynamic load testing, misalignment tolerance, material durability standards. Every one of those requirements was written after cars failed in exactly the way engineers said they would. Next time you close your hood and it feels like you need 2 hands and a running start to get it to latch, remember what it replaced. Drop a comment and tell me which one of these shocked you most. And next time I am breaking down the safety features that manufacturers quietly removed in the last decade that you did not notice were gone until I tell you. Some of them you used every single day. Or you thought you did.